from the public network to learn routing. Because routing is basically running on the public network. Knowledge exchanged only within the enterprise. E.g. VLAN. There is a protocol running on the public network called BGP. It is very typical to use the number of the autonomous system. You can understand the autonomous system as a network system. Can also be understood as it is a network architectural problem. Then usually a unified manager. The network to build. We call it an AS. This is its basic concept. Then usually within an AS will run the same protocol. This protocol is a dynamic routing protocol. And the strategy is relatively simple. That is, in the future, you will operate and maintain a set of enterprise networks. Then you must plan ahead. For example, some functions that enterprises must implement now. Some gateway configurations to be performed. Configuration of some strategies. Some controls. Configure an ACL. Etc. All the technology you use. Strategy of use. Relatively speaking, it is relatively simple. It's all just to serve the enterprise now. That is to say, now you maintain these 5 or 6 routers in your company. Built a network system like this. It can be said that you maintain an AS. So as is just a title and representative. From our point of view, we can say, a network system built by myself is an AS. But actually from the perspective of the whole world, 5 or 6 routers are an AS. So if this is operator A now, it is also an AS. Our devices need to be interconnected. There are a lot of equipment. Various strategies. There are also various configurations. Then I will maintain the network of operator A. Also an AS. Then the same. Let's say this is carrier B's network. It is also an AS. They also have a lot of equipment inside. There are many configurations. And the network management involved are called an AS. But they will apply for an AS number separately. For example, carrier A is AS 100. Carrier B is AS 200. This is the AS number they applied for. To us, a small AS defined is called a private AS. This is called a public AS. AS maintained by yourself. The outside world is not recognized. But for these AS running on the public network, they have real value. Even if you maintain a router at home, it can also be said that it maintains an AS by itself. It does not matter. Because this kind of thing is not recognized by the outside world. But conceptually it can be called like this. Public AS requires a separate application. Here's the difference between them. You first need to know. Actually, when we go to data communication now, assuming this is a one-by-one business, the egress of the enterprise is connected to the network of operator A. What we are using now is the network of operator A. We can also connect to operators in other countries. For example, they are AS 300. Then they will also interact with each other's data. The configuration of each other's routing protocols will also be performed. Also run some dynamic routing protocols to help the construction of network communication. It's just the internal protocol it runs. Basically the same as us. All in one AS. But they also run other protocols. These will be put in NP. Now there are 5 or 6 routers in the enterprise. It is here to operate and maintain. Then this is actually a private AS. Only, it does not connect with things on the public network of operators. Nothing more. But its concept. We'll talk about dynamic routing protocols in a minute. We'll revisit this concept. So here we must first have an understanding. Okay. Let's move on. We're talking about overall broadcasting. So now it's time to discuss a question. When we network based on switches, its actual network range is very small. The scope of the broadcast is under a broadcast domain. Then it is actually a network segment. Or, when we learn VLAN in the future, dividing VLANs will also have different webcast domains. So the network segment is not accurate. Let's just say it's a broadcast domain. Then it stands to reason. For example, now I have a broadcast data frame. Purpose MAC all 1. Written in hexadecimal is all F. Is a broadcast frame. I can flooding in the second layer network. Then the largest area of flooding is a broadcast domain. Now communicate based on the second layer. Only within this range. ARP we learned in the last lesson. It is a broadcast. This data is sent to the router and it is gone. Data forwarding is not possible. Then if you want, data goes from this device to this device. Now if the data gets here, if only communication within the broadcast domain is used, this data is impossible. We're going to pass the routing function. Just like the cross-network segment access I mentioned just now. As long as the host finds that the source IP and destination IP are not in the same network segment, it is now the process of finding the gateway. Is in the process of routing. This is the same. Data is now going from a broadcast domain to another broadcast domain. Then it is impossible to communicate directly. Must rely on the routing function of the router to help us communicate. So this will involve the concept of routing. Today I will simply explain these pictures around. When a data reach this router, RA. When the data comes, each layer of data is encapsulated. It first needs to see if the purpose MAC is looking for it. If not, it discards. The principle of the second layer is, first check whether the target MAC is for yourself. Deal with it if it is. If it is a broadcast, also handle. If it is a multicast, also handle. After watching the second floor, just look at the third floor. For example, data is going to this router, RD. Then RA will think about it now. RD wants RA to help it forward data. It's going to find this router. But RA doesn't know where this router is now. Unable to forward data for RD. If possible, RA will help it. If not possible, then RA will discard the packet. What we said. Is there any information about the destination network segment? We call it. Is there a routing entry to the destination network segment? We will focus on this routing entry today. Before talking about routing, let's review the simplest data. Two devices. They are on the same network segment. We call such a device connection as direct connection. Then the future network. Certainly not all devices are directly connected in pairs. In the future, there will not be only two adjacent devices for data communication. It's not that once the device is crossed in the middle. It's not a direct connection. The communication between them will rely on the function of routing. Because it is directly connected, they can communicate directly. This is the first concept we covered. The concept of routing. So if there will be multiple devices in the future, the data is going to the destination network segment. After passing through other routers along the way, then the data is sent. Will be on this router. To query a local representation. Routing table. According to the route 1 by 1 in the routing table. Direct data forwarding.